All right, Rob Agnew, Oklahoma State, Stillwater, Assistant Professor, Fire Protection and Safety Engineering Technology. And PowerPoint is a useful tool, but it has its limitations, and sometimes we need a different visual presentation form. And so I'm going to show you Prezi. Anybody ever used Prezi before? And so Prezi it's not spatially bound in a slide. It is a open canvas format. I will say they take longer to develop than a PowerPoint, and so I don't use them for my pretty pedestrian lectures. But when I'm dealing with spatial data, I like to use that. So this is an active investigation, root cause analysis that I'm using Prezi for. It's also, we're going through this thing about using it for process hazard analysis and design reviews. We're dealing with an entire floor plan, and this allows you to zoom in and out and move around in space around the topic. So this is the term rookie. This is when our students join the program. A lot of them will join a social organization called the Fire Protection Society, and they have Rookie Week, which they do all kinds of stuff around town. They do some philanthropy, they do history night, Better Than McDonald's night. I think we're changing the name of that, but basically students come and talk about their internships and career opportunities. But the big event is Rookie Night that kicks it off, and they go out to fire service training. We put them in bunker gear. They'll go and practice doing some hose techniques. They'll do a smokehouse, and then different kinds of games. We do hose bowling, where we set up a bunch of fire extinguishers, take a fire hose and roll it, knock them down. And up until this incident, they used to play tug of war. We had a couple tug of war incidents. And so they were playing tug of war, and unfortunately, we had one of the rookies suffer a fractured skull. The brass coupling of the fire hose came loose and hit her right above the eye and fractured her orbit. So this resonates with the students. We're using an example of something a lot of them at the time were there and familiar with it. And so this is based off of the Sologic root cause analysis software, if you're familiar with Sologic, where they like to tie basically two causing events together for that. So she suffered this, and it's because her head came in contact with the fire hose. It's a direct proximate cause of the injury. So we started asking, well, how did that happen? I don't know if you can see this in a way. But we have, the head was in the path of the hose. That was a condition that was there, and the hose coupling had sufficient force to fracture the skull. Okay, so those two components have to be together. Right? So the hose can be moving plenty fast, but if the head's not in the way, you don't get the interaction. And so the Sologic one keeps going through this. Why was her head in the path? Well, rookie fell and the team let go. Okay? And so this one, we're going to go down a different causal path and connect them together instead of continuing on this one by itself. The other one, why did it have sufficient force? Well, it has sufficient mass, right, and it had sufficient impulse, right, velocity. Okay, and why do these things occur? Okay, well, couplings are made of brass. We can go that way, or we can come down here and say the team that this person on was smaller than the other team, right, and there was a reason for that. And so we can examine it. Okay, we had that rookies were lined up by height and counted off by 8. Right. So obviously team 1 is by nature going to be smaller than team 8. So, and that was a traditional procedure. That's how it was done. It wasn't just random. And so why is this? There's no really reason to go extend that further. We know it was tradition, that's how it was done. And then it was the traditional procedure. There was no risk assessment for that. Right? And we didn't identify the need for a risk assessment. So if we don't have this piece with this one, we're blaming somebody. Right? We have to identify that no, there was no call for that. And there's no reason to go further. We have a root cause that we're looking into. Okay, so now we can go back up. We run that other path down. Why was her head there? Okay, and we're going to go back up to this coupling. It had mass. It was attached to the hose, and the hoses were made of brass. Okay, why are they made of brass? Because that's what fire equipment is made out of. There's no point continuing that for our investigation. But the coupling was attached to the hose. Well, here we get into a problem. Okay, the coupling had not been removed, and again, the hazard assessment said to remove the couplings. So if we didn't have this piece, and we just said this, we're blaming somebody again. We have to tie these two pieces together. Okay, so we wanted them to do a hazard assessment. They did, so that's not a fault, and we're going to stop that. So why had the coupling not been removed? So the senior that We have rookies and seniors. Seniors are the upperclassmen. So they weren't aware of the hazard assessment. And I thought, well, why'd you do that? Well, I didn't know there was a hazard assessment. So obviously we have a problem there. The other one was the prepared hose is not available. The team had actually gone through and prepared some hoses to cut off couplings. Okay. Well, what happened? It was in the back of this guy's truck, and it was helping tow our fire truck that broke down. 1927 fire truck. It lost a shear pin coming back from the station, so all the hoses were in the back of the fire truck. So you look at the other guy. Well, the person who was supposed to be running the event was not there. Somebody else stepped up, started to do it. They hadn't been briefed with the risk assessment, and so we see we have a problem. Okay, so that was not present at the safety briefing. So senior unaware, and we did not identify a need for attendance at the safety briefing. So only the organizers were there of those events, not in charge. So we need to go in, and that's a cause to work on that. And so you can see the large spatial data in a root cause assessment, and we can move through it rather than trying to go through in PowerPoint and break it into chunks. This way we can see the overall flow. The same thing, think about this being a blueprint of a facility, and we want to do a design review, looking at egress, things like that, same thing. We can zoom in on different parts of it and move throughout the blueprint, or process hazard analysis, when we're putting together a process flow, looking at chemicals and inputs, all that we can put together in a large spatial array. It's a really nice tool for those sorts of data presentations. And this is Prezi. Go to prezi.com, Prezi.com. And again, with your EDU account, you can get access to this. It's all online. The only caveat with the free ones is your presentations are publicly available. So you don't retain any kind of copyright or anything on them. But so this is up on the web, and you can get access to it. But there, it's just a nice way when you want to do the spatial data. It's free. So just a caveat, you can't keep the copyright on it.
Seems like students are using a lot of Prezi. They've got the opportunity for presentations,
Mm-hmm.
or whatever, that they often end up with a Prezi.
Yeah.
And Rob, you don't end up with that as a file on your computer, it's a file on the web, is that correct?
It is. There is an application you can download, and you can create this on a thumb drive. They're enormous because you have to download the entire engine behind it. So you're looking at like a 180 megabyte file to do this on your on a thumb drive. But yes, you can do it. It's just a whole lot cleaner to do it on the web. Any other questions about Prezi?
Cool. Thanks, sir.